I wanted to do a quick supplemental to multiplying polynomials because I wanted to show how trying to apply FOIL isn't always effective, especially when we're multiplying two different size polynomials. This one is a binomial and I'm multiplying it to a trinomial. And so if I try to do first and then outer and then inner, I don't know whether to go there or to go there. And then I could still do last. Even if I did both of those, notice that I completely missed multiplying the a times the ab here. So FOIL really isn't our friend. Let's try the box method. The box method was far and away my favorite method here, so let's go ahead and see what that looks like. I'm going to make a 2 by 3 box. So here's my rectangle, and I'm going to cut it up into a minus b, so it's going to be 1, 2, there's my 2, and then I'm going to have a squared, that's 1, my positive ab, that's 2, and then I have a positive b squared that I'm multiplying by. And there's my, not the prettiest box, but you can see. So this is an area model. We used it earlier. It's a length times a width. It's pretty much the same kind of multiplying you've been doing since the 3rd grade, only our numbers look a little different. So let's see what happens when I multiply this out. A times a squared is a to the 3rd power. A times a positive ab is an a squared b, that's positive. A times a positive b squared, well, that's a positive ab squared. Now let's take this negative b and distribute to our 3 parts there. Let's do that in a different color just for the sake of having some fun with color. Let's try a green. Negative b times a squared is a negative a squared b. Negative b times a positive ab is a negative a. B times b is b squared. And a negative b times a positive b squared is a negative times a positive is a negative b to the 3rd. Now remember, whenever we're using this area model, we have like terms at the diagonals. My middle terms in their diagonals are like terms. Now look at what happens. Something very interesting happens there. Well, this a to the 3rd power doesn't have a like term to go with it, so we're just going to bring that down. That's an a to the 3rd power. But here I have the same term. One's positive and one's negative, so these guys actually cancel each other out. And the same thing here, a negative ab squared, a positive ab squared, so those guys cancel each other out. And the only other thing I'm left with is the minus b to the 3rd power. I have the difference of cubes there, huh? That's interesting. Let's try another one. Let's try x plus 3, and let's multiply that by x squared minus 3x plus 3 squared. Let's square 3 and make it 9 plus 9. And I know you're thinking, Rodriguez, it looks like you did something a little shifty there, and I did. I wanted you to see, this is pretty interesting that here, multiplying this binomial times this binomial, we ended up with a difference of 2 cubes. What happens if we multiply this binomial times this binomial? Well, let's draw our little area model. Here's our box. Not the most perfect box, but it does the job. We have an x there and a positive 3 there. And then in purple, let's say, we'll do our x squared minus 3x and a positive 9 there at the end. Alright, let's see what happens. X times x squared is x cubed. X times a negative 3x is a negative 3x squared. X times a positive 9 is a positive 9x. So far, so good. Now let's take this positive 3 and multiply it out. Well, 3 times x cubed is x squared is a 3x squared. That's a positive. 3 times a negative 3x is a negative 9x. And a positive 3 times a positive 9 is a positive 27. Let's go to orange, and let's see what happens with our diagonals. Positive 3x squared minus 3x squared. Those cancel. Negative 9x plus 9x. Those cancel. And all I'm left with is x cubed plus 27. Or another way of saying 27 is 3 cubed. So here we have the sum of two cubed numbers. Please make sure you make a note of those because we're going to talk about that.